Hi guys, see the diagram, not drawn to scale. A rectangular pen ABCD is to be constructed such that there are similar rectangular pens EFGD, HIJD, and the area of ABCD over EFGD is equal to area of EFGD over the area of HIJD. The amount of material used to construct the required additional sides EFGD and HIGD is equal to half the material required to construct ABCD, then the area of HIJD over the area of ABCD is equal to big number. Okay, so this is telling us, the area of ABCD over, so ABCD area is the AB length times the CB length over, I'll use D because all of them use D, AD times CD over ED and GD, ED times GD is equal to, and then it's going to be again ED times GD over HD times JD. Okay. The amount of material required to construct the additional sides for EFGD and HIJD. So I guess it's just going to be ED, because this is the same as this. I'm not going to be using F or I because I don't need to. ED plus GD. ED plus GD. Are these? Okay, I want to simplify this in a second. HD plus JD. Is equal to 1/2 is equal to 1/2 times, it's going to be 1/2 times 2AD times 2AD plus 2 this, so it's just going to be AD plus DC. Okay, these are our equations. We can simplify this though. If we have this larger one, we just need like K1 and K2. So if we have, we call this base, we call this height. We have base times height over K squared base times height is equal to K squared base times height over, and then do we know, are they similar to each other? No, it's just going to be K, I'm going to use Q squared base times height. So these cancel out. We have 1 over K squared is equal to K squared over Q squared. So we know that these are the same-ish. Multiply by this, multiply by this, we get Q squared is equal to K squared, K to the 4. So this is telling us that Q is equal to K squared. Okay. I had assumed that, I thought that was said in the question though. So, we see here ED, JD, wait, what? Oh, GD. Okay, so this is going to be K base. It's going to be K base plus height plus, it's going to be k squared base times height, base plus height, is equal to base plus height. Okay. So, can we turn this into a quadratic to solve for k? Wait, I want to see what this is asking. Hij(d) over abcd? That's just going to be k squared. No, it's going to be k to the 4. I think. Let me check. Hij(d), so it's k squared times k squared. Yeah, so it's just going to be k to the 4 is what we're looking for. So can we just solve for the quadratic here? If we say base plus height is equal to x, we say k squared x plus kx minus x is equal to 0. And then, I mean, we don't know what base or height is. Okay. So we have these two unknowns, which is a bit scary. So if we solve for k is equal to negative x equals negative b plus or minus the square root of x squared minus 4a plus 4x squared all over 2x. So, ooh, this is looking like a quadratic. So this is equal to negative x plus or minus the square root. It's going to be x root 5 all over 2x. Ooh, we can cancel out the x's. We get negative 1 plus or minus the square root of 5 over 2. So it's going to be plus. We don't want the minus. So it's going to be negative 1. It's going to be root 5 minus 1 over 2 to the 4. Root 5 minus 1 over 2 to the 4. So root 5 minus 1 to the 4 over 2 to the 4. 2 to the 4 is 16. Okay. This is going to be this squared, so it's going to be 5 minus 2 root 5 plus 1 squared, which is just 6 minus 2 root 5 squared. So then we get 36 minus 24 root 5 plus 4 times 5 plus 20. So we get 56 minus 24 root 5. 56 minus 24 root 5 over 16. These both share a factor of 4. This is 10, this is 14 minus 6 root 5 over 4. Oh, they also share a factor of 2. 7 minus 3 root 5 over 2. The sum of all of these, 7 plus 3 is 10, so 17 should be our answer. Let me check. I forgot to record an outro, but it is in fact correct. I did it exactly the way that they did it, which I'm very surprised about because that was a hard problem, but I got it correct. Cool. And it was a geometry problem, which I'm not the best at. Thank you guys for watching. I'll see you guys tomorrow. Bye.